Hello everyone, welcome to my math class. In this video, we are going to look at logarithms. Let's get started. First, let's turn back the clock. At primary school, we first learned addition. For example, 2 plus 3 is equal to 5. And then, at some point, if we don't know this number in this addition, how we can express this unknown number. At that point, we learned subtraction. This box is equal to 5 minus 2. Therefore, we know addition and subtraction, they are opposite operations. Then we move to a higher level. We learned multiplication. For example, 2 times 3 is equal to 6. Then, at some point, we don't know this number 3. Then how can we express this unknown number? So this unknown number can be expressed as 6 divided by 2. Therefore, multiplication and division, they are opposite operations. Now we know exponential form. For example, 2 to the power 3 is equal to 8. Then the question is, if we don't know this index here, now how we can introduce the opposite operation to express this unknown number? And this one will be our topic for today, logarithm. Now let's focus on the exponential form. 2 to the power 3 equals 8. In this expression, number 2 is the base, and the index 3 is called exponent, and the result is equal to 8. And if we would like to express this exponent, we are going to write down in this way. 3 is equal to logarithm, we just use log to represent logarithm, and the log of 8 to base 2. And this one is called the logarithmic form. In this form, number 2 is still the base, so it is written as a subscript. Number 8 is called the argument of logarithm, or we just call it logarithmic argument. Number 3 is the exponent. By comparing them, we know the base is always base. Now we are going to generalize these ideas. In the exponential form, we have a as base and the exponent is x. If we want to express this exponent, then we can write down this way. X is equal to the logarithm of b to the base a, and this form is called the logarithmic form. In this form, a is still called the base and b is the argument of the logarithm. By comparing these two forms, we can see the base is always the same, and there is a restriction for the base, so base a should be greater than 0, and it cannot be number 1. Also, for the argument of the logarithm b, it should always be positive. Now let's practice how to convert the exponential form to the logarithmic form. Firstly, we have 5 squared equals 25. Here, number 5 is the base and 2 is the exponent. And using the logarithm, we will have 2 is equal to the logarithm of 25 to base 5. Then for part B, we have 3 to the power 4 equals 81. Similarly, for this expression, the base is 3 and the exponent is number 4. Then we are going to use logarithm to express number 4. 4 is equal to the logarithm of 81 to the base 3. Then move on to the second exercise, how to evaluate the following logarithms. First one, we have logarithm of 32 to base 2. Now what will be the value? So for this one, the value we don't know, we can express this one as x. And then we can convert this logarithmic form back to the exponential form. Then base here is number 2. So base is still the base. And x is the exponent. So 2 to the power x equals 32. So we're going to think about what power of 2 gives 32. Then 32 is 2 to the power 5. Then we know x is equal to 5. Now for the second question, we have the logarithm of 1000 to the base 2. Then here the base is number 10 and 1000 is called the argument. And in order to get the answer, we can ask ourselves, what power of 10 gives 1000? So it can be written as exponential form. 10 to the power x equals 1000. And 1000 we know it is 10 to the power 3. Therefore, the expression is 3. Now for the third question, we have the logarithm of 36 to the base 6. And this answer should be number 2. We can ask ourselves, what power of 6 gives 36? So it means we convert this logarithm back to the exponential form. So 6 is the base. And 6 to the power x is equal to 36. And 36 is equal to 6 squared. Therefore, x is equal to 2. That's all for this video. Thank you very much for watching.